Hello, future engineers and fellow engineers. Today, I'm going to discuss frames and machines. This is lecture 32 of statics. And let's proceed directly to the examples. And if you're still new to my new YouTube channel, so that I will be inspired to do more lecture videos that will be of help in your studies, please don't forget to subscribe. So example 1, for the frame shown, determine the horizontal and the vertical reaction at the pin A. So let's have this solution. So first, let's consider the whole system. Let's put the component reactions. Let's sum up moment about A. These are the component reactions equals 0. So summation moment about A equals 0, considering counterclockwise as positive. So AH is counterclockwise. AH times 3 minus AV times 3, then minus 150 times 7.5 equals 0. Simplifying, 3AH minus 3AV equals 11,000 or 1,125. Call that equation 1. Then let's isolate member AB and draw the free body diagram. Then we sum up moments about B equals 0. So the vertical distance of AH is also 3. So summation moment B equals 0, clockwise positive. So AH times 3 plus AV times 6, then minus 600 times 3 equals 0. So simplifying, AV is equal to negative 0.5 of EH plus 100. So AV is negative 0.5 of AH plus 300 rather. So substitute this in equation 1. So 3 times EH minus 3 times negative 0.5 EH plus 300 equals 1125. Solving for EH, which remains the unknown in the equation. So AH is 450 newtons, and since it is positive, its direction is leftward. Likewise, substitute into this equation here the value of EH. So AV is negative 0.5 of 450 plus 300. So AV is 75 newtons and it is positive, so upward direction. So let's have the solution of example 2. Determine the couple M at A that will maintain equilibrium at a given position of the three-link mechanism shown. The loads act at the midpoints of the links. So this is the given figure. Remember that the loads act at the midpoints of the links. So first, let's have the component reactions at A and D. So these are the assumed directions. Then we consider the whole system, summation moment about A equals 0. So we anticipate that the couple at A is counterclockwise because the couple or the moment of the loads are clockwise. So summation moment about A, considering counterclockwise positive, equals 0. So we have MA plus DH times 60 plus DV times 360, then minus 500 times 90, that's 90, minus 250 times 90 plus 180 is 270, so minus 250 times 270 equals 0. So simplifying, MA plus 60 DH plus 360 DV equals 112,500. Call that equation 1. And let's consider member BC. Let's draw the free body diagram. And let's sum up moments about B. So let's assume these are the direction of the component reactions at C. So summation moment about B equals 0, clockwise as positive. Since CH is counterclockwise, so negative CH times 240 plus CV times 180, then plus 500 times 90 equals 0. So simplifying, 240 CH minus 180 CV equals 45,000, equation 2. Then let's draw the free body diagram of CD. Let's transmit these forces like that. So summation of moment about D equals 0, then we can now compute CV. So C sub V clockwise positive, CV times 180 minus 250 times 90 equals 0. So C sub V is 125 newtons upward. Likewise, summation forces X equals 0, so CH equals DH, or negative CH equals DH, or plus DH equals 0, or CH equals DH. Then summation forces Y equals 0, C sub V, which is 125, plus dV equals 250, or dV is also 125 newtons. Now that we found dV, we substitute this, we solve for C sub V. So C sub V is 125. Let's substitute C sub V equals 125 into equation 2 to solve for CH. So 250 CH minus 180. This is 180 C sub V. C sub V is 125 because 45,000. So CH is 281.25 newtons. Then since CH equals DH, DH also is 281.25 newtons. Now that we have found DH and dV, dV is 125, let's substitute that into equation 1 to solve for MA. So DH is also 281.25, take note. So MA plus 60 times 281.25 plus 360 times 125 equals 112,500. So MA can now be solved, and it is positive 50,625 Newton mm, or in Newton meter 50.625 Newton meter counterclockwise. So that's it. That's the solution to this problem. This one example, example 3 on machines. An elevating dump truck body is activated by duplicate linkages on each side of the truck. At the position shown, find the force P in the hydraulic cylinder BC and in the links CD and FG if the total load W is 46.8 kilonewtons. Neglect the weights of the linkage and note that each set of linkages supports half the total load. So the figure shows only one set of the linkages, and therefore this W here must be divided by 2. So if you look at the figure, if we consider only the vessel, the container with weight W over 2, and we have a force on GF or FG on this link, then if we sum up moment about E, then we can solve for that force in FG. So the slope of FG are 0.3 and 0.45 vertical, 0.3 horizontal, so which can be reduced to 2 horizontal to 3 vertical, and the hypotenuse is square root of 13. So consider FDD of the container. So it's now these are the component reactions at E, not important, so we expect that the component reaction at G would be the force on the link is compression, so the components are upward and leftward. So for the leftward force, it is FFG times 2 over square root of 13. The vertical component is FFG times 3 over square root of 13, because we have 0.45 divided by 0.15 is 3, so 3 vertical, then this is 0.3 over 0.15, 2 horizontal. Then the horizontal component is FFG times 2 over square root of 13. Then for the distances, the horizontal distance is, if you look at the figure, we have here 1.8 plus 1.9 is 3.3. Then the horizontal distance rather is, because this is 2.4 minus 1.5 is 0.9, so 3.3 plus 1.9 is 4.2, the horizontal distance. So this, I'll call that Y. By similar triangles, Y as to 1.5, equals 2.1 as 2, 0.3 plus 1.8, so 2.1 also. Y as to 1.5 equals 2.1 as 2.1, so y is 1.5 meters. So then this distance is 0.9 plus 1.2 is 2.1 minus 1.5, so this vertical distance of A and C is 0.6 meter. Then for this distance here, call that y1. So this is also y1, this is also y1. So y1 as to 2.4, because that's 2.4, equals 1.2 as to this horizontal distance here between B and D is 0.6 plus 0.6, 1.2 plus 1.8, 3. 1.2 as to 3. So y1 as to 2.4 equals 1.2 as to 3. So y1 is equal to 0.96 meter. That's the value of y1. So for the vertical distance, therefore, between G and E, it is 2.1 minus 0.96 plus 0.45. 2.1 minus 0.96, that's 2.14. Oh, sorry, 1.14 plus 0.45, 1.59 meters. The horizontal distance is, as I said, 1.8 plus 2.4 is 4.2, and that is 0.9. 4.2. 0.9 is 2.4 minus 1.5 is 0.9. So summation moment about E equals 0, counterclockwise positive. So both these components are counterclockwise. So let's begin with the horizontal, FFG times 2 over square root of 13 times 1.59 plus the vertical component, FFG times 3 over square root of 13 times 4.2. Then minus 46.8 over 2, we divide the weight by 2 times 1.8, then equals 0. So from here we can now solve for FFG. FFG is 9.624 kilonewtons. Then next we break C and we replace the force in BC as P and the link CD as FCD, and there are two components also. So that P has two components, PH and PV. Then at D, there are also two components, let's say downward and leftward. So we have FCDH and FCD vertical. So we break C. So these forces P and FCD pass through C. So if we sum up moment about C, then we can solve the horizontal and vertical components at A. So summation moment about A equals C equals 0, clockwise is positive. So we have EH times 0.6 plus AV times 3.3, 3.9, 4.5. 3.9, sorry, we sum up moment about C, so 1.5 plus 1.8, 3.3 plus 0.6, 3.9. Then take note that these forces are not involved because P passes through C, and the force in the link CD is along CD, so it passes through C also. Then we have weight, so which is counterclockwise, so minus 46.8 over 2 times the distance 2.4 minus 1.8 is 0.6, this is 0.6 plus 1.8, 2.4 plus 0.6, 3. So the moment arm of weight is 3, W over 2 is 3. then equals 0. So simplifying, 0.6 AH plus 3.9 EV equals 70.2. Call that equation 1. Then next is we sum up moment. Let's consider the free body diagram of ABE. Then we sum up moment about B. We may include the horizontal and vertical components of reaction at B. But because we sum up moment about B, those reaction components are not involved in the equation. Then we transmit the forces in link FG. So since it is compression or up to the left at G, then it is rightward and downward at F. So the components of FFG are FFGH is equal to 9.624 times 2 over square root of 13. So it is 5.338 rightward if you transmit that at F. Then FFG vertical is 9.624 times 3 over square root of 13, and it is downward, and it is 8.008 kilonewtons. So this is now the free body diagram of the portion ABF. Then you may include the component reactions at B if you want. So these are the components of FFG, 5.38 rightward and 8.008 downward. Then also at AH and AV, but because we sum up moment about B, so we have an equation in terms of AH and AV, our equation 2, so that we can solve for AH and AV. So first, the vertical distances. The vertical distance between F and B is 2.1. Between B and A, it's Y, or 1.5. 2.1, 1.5. For the horizontal distance between A and B is 1.5. Between B and F is 2.1 also. So these are the component reactions at B, Bx, By, but we sum up moment about B equals 0, considering clockwise as positive. So negative AH times 1.5 plus AV times 1.5, then plus 5.338 times 2.1 plus 5.338 times 2.1 plus 8.008 times also 2.1, then equals 0. Simplifying, we have negative 1.5 AH plus 1.5 AV equals negative 28.027. Solving equations 1 and 2 simultaneously. So this is just two equations to unknown, so you can manage to solve for AH and AV. And the reason I do not show the algebra anymore, because we ran out of space. So the solution will just be enough in this page, in these slides. So H is 31.793 kilonewtons, and since positive, it's rightward, and AV is positive 13.109, so it's also upward, the figure. So finally, we go back to this free body diagram. So it's like cut here. So we consider this entire body, and we break C. So P and FCD are represented by their components. So summation. So PH, by the way, is P times horizontal component of distance is 1.8 plus 0.6 is 2.4. Then the vertical component is 1.2 plus 0.9 is 2.1. So it is equal to P times horizontal component of distance divided by distance, 2.4 square root of 2.4 square plus 2.1 square is equal to 0.7526 P. P vertical is, you just replace 2.4 by 2.1, and in decimal form is equal to 0.6585 of P. So summation of moment about point D equals 0, clockwise positive. So we have PV 0.6585 times 2 times 3, we sum up moment about D. So 1.8 plus 0.6 plus 0.6 is 3. And minus pH, which is 0.7526 P times 1.2. Then plus EH, which is 31.793. Sorry, minus EH, it is counterclockwise. So the distance is 0.9 minus 0.6, so 0.3 for counterclockwise. So my plus AV first, 13.109 times 3.3 plus 1.2 is 4.5. Then minus EH, 31.793 times 0.3. 0.9 minus 0.6 is 0.3. Then minus the moment of the weight over 2. Weight over 2 is 23.4. The distance is 0.6 plus 1.8, 2.4, 2.4 plus 0.63, 3 plus 0.6, 3.6. So 23.4 times 3.6 equals 0. So we only have P as the unknown. We can now solve for P. P is 32.44 kilonewtons. Then, having found P, let's now solve for FCD. This time we sum up moment about B equals 0. So clockwise as positive, FDH is clockwise, FCDV is also clockwise. So FCD is the horizontal component of FCD. This is 0.6, 0.9, so we can reduce that to 2 horizontal, 3 vertical. So the hypotenuse is square root of 13. So FCDH is FCD times 2 over square root of 13, then times moment arm 1.2, then plus FCD vertical is FCD times 3 over square root of 13. The moment arm is 3. 1.8 plus 0.6 plus 0.6 is 3. That distance. Then, because we do not touch this part, these are interior linkages, then we only consider EH and AV. So EH is counterclockwise, so minus EH 31.793 times Y, which is 1.5, plus A vertical, because it is clockwise, 13.109, A vertical, moment arm is 1.5, then minus AH 31.793 times 1.5, then minus the weight, moment arm is 0.6 because 2.4 minus 1.8 is 0.6. W over 2 is 23.4 times 0.6 equals 0. So solving for FCD, the only unknown FCD is equal to 13.404 kilonewtons. So these are the answers. So we still have space here. So let's check summation forces horizontal. It is 0. So summation forces horizontal equals EH 31.793, then minus PH, which is PH minus 0.7526 times 32.44, then minus FCDH, FCDH is minus 13.404 times 2 over square root of 13. So computing this value, that is almost 0, so that checks. So I will leave the other checking, which is summation versus y, and it must be also almost 0. So to validate these 3 answers. So I hope that you were able to follow the solution, though it's very tedious because of the very small space that we have, but I still managed to explain it for you. So I hope you can follow it, and especially for mechanical engineering students. This is only for mechanical engineering students, but if you are good on the construction of free body diagram that is very important also as engineering students. So I hope you enjoy watching. Bye.